Good day. This lesson will be all about common fractions, the basic knowledge of comparing and converting. Let's say I give you a chocolate and you may eat one piece of this chocolate. What fraction are you allowed to eat? Let's see. If I break this off and you can eat it, what fraction will you be able to eat? The chocolate was divided into 4 equal parts. And you were allowed to eat one piece of the parts. So you were allowed to eat 1/4 of the chocolate. Happy? No, some of you might have wanted more, ne? Okay, but you were allowed to eat 1/4. Or we can say you are allowed to eat 1/4 of the chocolate. Now we write fractions like this. The top value we will call the numerator. And the bottom part we call the denominator. So the numerator is the top part and the denominator is the bottom part. But the denominator, and this is the most important thing, means that the chocolate, for instance, in this example, had to be divided into 4 equal pieces. Okay, let's say I take out another chocolate and I give your friend half of the chocolate to eat. And you still got 1/4 or 1/4 of the other chocolate. Who actually had the most to eat? Let's have a look at this visual representation. Your friend was allowed to eat half of the chocolate. So let's say this is the chocolate and it's been divided into 2 equal parts because our denominator is 2. You, on the other hand, had the same size of chocolate, but you were allowed to eat 1 piece of 4 pieces. Okay, so you were allowed to eat 1/4. Now, if you have a look at these 2 examples, which piece is actually now the bigger one? Yes, I know you think it's unfair because your friend got more. But let me show you how to do it mathematically. If we need to compare fractions, the most important thing is that our denominators should be the same. We are now talking about comparing. And for the comparing part, denominator is the same. And to get them the same, we will make use of the LCM. LCM stands for lowest common multiple. But because we are working with fractions and numerators and denominators, we are changing the M now to LCD, meaning lowest common denominator. Okay, now your friend had half of the chocolate. You got 1/4 of the chocolate. Who got the most? We saw the biggest part was actually your friend. But if we need to compare this mathematically, we need to change it to the LCD. So, what's the lowest common denominator or the lowest common multiple between 2 and 4? It is 4. So, I can change this into 4s by multiplying it by 2. Now, I cannot just change it, multiplying my denominator, without using the fact that we need to have equivalent fractions, rather. So I need to multiply with the top, the 2 as well. So this half will become now 2/4. And you had 1/4. So who had the most? Your friend. So that was the bigger one. Okay. Now, let's do an example. If I'm asking you to place the following 3 fractions for me in ascending order. Ascending from small to big. It is 3/4 and 1/2 and 2/3. Now, you need to put these for me in ascending order. Which one is the smallest? Which one is the bigger one? very important, we can determine that only actually if we have the same size denominators. I have a denominator of a 4, a 2, and a 3. How do I get them the same? I must get the lowest common multiple of these three numbers, these three values. And what will be the lowest common multiple? 12. So I'm going to change that fourths to 12. I'm going to change the halves to 12. And I'm going to change the thirds to 12. So I'm again making use of equivalent fractions. To change the fourths to 12s, I need to multiply by 3. But then I need to multiply my numerator by 3 as well. So times 3. And this will become 9 twelfths. Here, I have a 2. I need to change it to 12s. I multiply with 6. The numerator and denominator, that will become 6 twelfths. I have thirds. I need to multiply by 4 to get it the same value. The equivalent fraction. The top and bottom multiplied by 4, so that will give me 8 twelfths. Now you can actually see which one is the biggest one. We have 9 twelfths as the biggest, then 8 twelfths, then 6 twelfths. But the question was that you had to put it in ascending order, from smallest to biggest. So the smallest one here will be 6 twelfths. But please, guys, write it in terms of the given fraction. So the smallest one was actually a half. And then the 8 twelfths, that was the 2/3. And then the 3/4. Okay, right. Now we have compared fractions with one another. The following part that we need to do is we need to convert fractions. Okay. So, most important thing, you need to understand that we have 3 types of fractions, of common fractions. 3 types. The first type is the proper fraction. And that means when I have a proper fraction, my numerator is smaller than the denominator. So I have a part of a whole. Let's do an example such as 2/5. Okay. The second one, we have improper, the proper fraction is the first one. The second one is improper fraction. Now, in the case of proper fraction, the denominator was actually bigger than the numerator. So when I have an improper fraction, my numerator will be bigger than the denominator. An example such as 7/3. The last one, what we have, we call a mixed number. And this mixed number, an example of that might be something like 2.5. Consists of a whole number and a fraction. Okay. Now, how do we convert? We can convert improper fractions to mixed numbers, and we can convert mixed numbers into improper fractions. So, let's convert. Let's do an example. I'm going to take an improper fraction and converting it to a mixed number. An example such as this one, 7/3. Okay, how do I change that? Now, 7/3, I'm going to show you 2 methods. 7/3 is actually 7 divided by 3. So if you write it as a division calculation, it might look like this. 7 divided by 3. And how will you do that? You might say, how many 3's can go into 7? It's 2. 2 times 3 is 6. Get the difference? There's 1 remaining. Can 3 go into 1? No. So there's a remainder of 1. So once you have this division calculation, you can see the answer will be 2 and 1/3 remaining. You can do this in another method. You can say, okay, 7/3 might be the same as 3/3, that's a whole, plus another 3/3, so we have altogether 6/3, plus 1/3 for the 7/3. So this will then be an answer, that's a whole, That's a whole. So it will be 2 1/3. It's the same answer. The more you work with this, the quicker you will actually get the answers. Let's do another one. Let's say 19 fifths. And you need to change this to a mixed number. So how many 5s can go into 19? Again, you need to know your times tables. 5, 10, 15, 20. It's too much. It's 3. So 3 can go into that. Okay? And how many fifths are remaining? How many fifths are remaining? 3 times 5, that will be my 15. And I need to get to 19, 15, 17, 18, 9, 16, 17, 18, 19. So 4 fifths will be remaining. So you can choose either method to do. But like I said, the more you use this, the easier and quicker you will be able to do this. Last thing. Now we have changed improper to mixed number. But I would like to change a mixed number to an improper fraction. So mixed number into improper fraction. Let's do an example such as 4 2/7. This is quite straightforward, guys. You can just say, I'm working with sevenths. So my answer needs to be in terms of sevenths. How many sevenths do I have? And this is where I say 4 times 7, that's 28. So I multiply this. Plus the remaining 2 at the top there will give me 37ths. And you can check yourself. If you take the 37ths and you change that now again to a mixed number, you need to get to the same answer. Let's do a last one. 3 5/9. Okay, it's a mixed number. We need to change to improper fraction. We are working with ninths, so your answer will be ninths. Okay, in terms of ninths. How many ninths? 3 times 9 is 27, plus the remaining 5 there, 27, 28, 29, 30, 32. That will be 32 ninths. Boys and girls, I hope you understand. We had a look at comparing and converting common fractions. And once you get the hang of it, it's very nice to do. Just think of a chocolate and maybe have a piece or two. Until next time, goodbye.